Good day, algebra students. So, lesson 5 today. We are graphing radical functions. So, check off that. So, flip over to page 11, graphing radical functions. Do you remember how we graphed the exponential functions? It's just going to be a little bit different. So, let's hop on down here and do our first one. So, our first function is the basic square root of x. Okay, so let's make a table and graph it. So if we put in 0, well, that's just the square root of 0, which is just 0. So that tells us we have the point 0, 0. And 1, so we put in 1 under our square root. Well, the square root of 1 is just 1. Pretty easy so far. Not all of them are going to work like this, though, so be careful. Put in 2, the square root of 2. Well, that does not simplify, but you can plug it in and get a decimal if that makes it easier for you to graph. So about 1.41 is the decimal for that. Radical 3, that's another one that doesn't simplify easily, so we need to get a decimal for him. That's about 1.73. And our last one here, the square root of 4, that's just 2. So now we've got these points and we need to plot them on our graph. So again, you can graph these however you see fit, okay? Whatever fits. So we've got 0 to 4 for our x's and 0 to 2 for our y's. So you could center it in the middle. I'm just going to go ahead and make it start down here. So I'm going to set 0, 1, 2, 3, 4 for my x's. And I only need to go from 0 to 2 for the y, so I'm going to go up by some decimals here. So maybe go up by like, oh, I don't know. Let's make this 1. And up here would be 2. So I could have gone farther, but that's okay. So 0, 0, I'm starting down here. 1, 1. So it's going to be about here. 2 and 1.4, so this would be 1.5, so I need to go a little under that. 3 and 1.7, so somewhere around there. 4 and 2, somewhere around there. So then we need to connect these. So let's just maybe zoom in a little bit and do it this way. So do you notice how it kind of has this curve again? It's just a little bit different. So our exponential functions, remember, had a curve like this. So if an exponent and a radical are inverses, well, those functions are going to kind of be inverses as well, which means their graphs are going to kind of look the opposite of each other. So exponent curves like up, and our radical function is going to kind of curve the other way. So that's what it's going to look like. We can get rid of these then. Okay. So any other radical function is going to have a similar shape. It's going to come out and curve like this. Remember, we can do these in our calculator too. So let's take a look at what graphing these on the Inspires looks like. So here we are with the TI Inspire. So we need to go to our graph option. So here's our function. Remember, f of x is y, so we don't need that part. So we need to put in the square root. So we're going to have to hit Control and then hit the x squared button to get that little square root key. Okay, so square root of x. And let's see what happens. Boom. There it is, just like we kind of graphed it on our paper. So it has this curve coming out and around. Okay. And remember too, you can always see a table of values if you press menu, go to option 7 for table, and click split screen table. And here are those same values that we got. We started at 0, so we got 0, 1, 1.4, 1.72. You could see some more with that. Get rid of your table, you press menu, go to 2 for table, and 1 for remove table, back to normal. So notice how on this guy, it stops here at 0, 0. doesn't keep going out into the negatives. Now, why might that be? Let's go back to our booklet and explore that situation. So for any even-powered root, so the square root, the fourth root, the sixth root, etc., we're not going to be able to plug in negative numbers. So that's an important thing to remember. Whoops, I need my pen. Ha ha ha. Now, why is that? It's because there's no real number that's going to result, so this is what I'm reading right here, and a negative when you square it. So that means if I try to take the square root of a negative, there's no number that would be a result of that, because nothing times itself is going to be a negative number. We'll explore that down here. However, an odd power will work with negatives. So let's take a look at what an even power, or like something like x squared here, how that behaves versus something like x to the third power. So we know that if we think about x squared, that means x times itself, right? So let's think about what that is if x is greater than 0. So if x is positive, we would have a positive number times a positive number, which is going to result in another positive number. What about if x is less than 0 or negative? We'd have a negative times another negative, and we know that a negative times a negative goes back to a positive. So do you see here how both options, whether we're positive or negative for our x value, is going to always be a positive number when we square it? There's no option to get a negative number. So if we try to take the square root of x squared, there's no number when you multiply by itself that's going to give us a negative. So there is no answer for a square root of a negative number. Now let's think about x to the third power. That means x times x times x. So if x is positive or greater than 0, we would have a positive times a positive times a positive, which of course is still a positive number. But what about if x is negative? Negative times a negative times a negative, and that is going to stay negative because two of the negatives are going to cancel into a positive, but then we've got that one more that's going to make it go negative. So in this case, there is an option to be negative. So odd power roots are going to have one of those negatives left over, which will make a negative answer possible. However, even powered roots, you're always going to have the negatives canceling each other out, leaving us with just positives. So hopefully that makes sense. Let's move on to some other graphs and see what those look like. So with our next example, on the next page, we have y equals the square root of x plus 3. And notice I kind of changed the values on you for the input, so for the x values. So let's think about outside here. If we plug that in, this would be negative 2 plus 3. So what would that be equal to? Negative 2 plus 3 is going to be the square root of 1, which we know is just 1. What if we plug in negative 1 plus 3? Well, that would be the square root of 2, which we got a decimal. We found that in the last one is about 1.41. What if we put in 0? Square root of 0 plus 3, that's going to be the square root of 3, which we got to be about 1.73. Put in 1, we get the square root of 1 plus 3, which is going to be the square root of 4. And we know that that is 2. One more here, we put in 2, we get the square root of 2 plus 3, which we know is the square root of 5. And we need to put that in our calculator. What do you get? About 2.24. Alright, so now we need to come over to graph. So since we have some negatives, maybe we'll kind of set this one up like maybe in the middle. So if we have 0, negative 1, negative 2, 1 and 2 for our x's, and then let's look at our y's. We go from 1 up to a little over 2, so maybe going up by 0.5 or a half. So let's go up and make 1 here and 2. All right, so let's graph. Our first input was -2, and we got that to be 1. So we put a dot there. When we put in -1, we got about 1.4. So somewhere around there. When we put in 0, we got about 1.7, somewhere around here. When we put in 1, we got 2. And when we put in 2, we got 2.2. Now this one you might say, that looks a little linear. And it does. And it's because we have such a small section of it. So it is slightly curved though. And if we think about this, we could actually check one more value. Let's do that down here. Because we never got 0, so we could actually plug in -3. That would give us a square root of 0, which would be 0. And then that's going to finish off what our curve would look like. So if we made it -3, and then that would be all the way down here at 0, 0, or not at 0, 0, but -3, 0, then that really kind of makes the curve stick out. So it's kind of more like this. And if you continued further out the other direction, you would notice a very, it would eventually really start to level off, something like this. Okay? Again, you could put that in your calculator and see what it looks like, but let's move on to the next one. This we have the cube root of x. So if we put in -8, so notice I changed the numbers again, but if we do the cube root of -8, I guess we don't really need to put that there. That's going to give us -2. Cube root of -1 is going to be -1. The cube root of 0 is just 0. Cube root of 1 is 1. And the cube root of +8 is going to be +2. So to come over and graph, our x's are going from -8 to +8. So we need to figure out how to label our graph to make that work. So it might be good to go by 2. So let's do 0, 2, 4, 6, 8. And on the other side, then we have -2, -4, -6, -8. And our y's, we go from -2 to +2. So maybe again going by like half. So this would be 1. This would be 2. And we need negatives this time. -1 and -2. Okay, so let's graph. So our first point was -8, -2. So that's down here. And then -1, -1, that would be somewhere right around here. 0, 0, 1, 1, and 8, 2. Move over a little bit. So now look at how this one looks. Whoops, I totally missed that. There we go. I still miss it. Man. There we go. It's a little bit better. So this one kind of has like an S kind of shaped curve to it. And that's because it's a cube root. So any odd power root is going to have like an S curve where you do have the option to go into the negatives. But if it's an even powered root, all it's going to have is this section. So the part that comes and curves up and outward. Okay? All right. So try graphing some on your own with your assignment and make sure to ask questions if you need some help.